Salam sejahtera to Dr. Fariza. My name is Enkaisin, and with my team member CHITTANA will be represent a assembly piston in this assignment. First, introduction. A piston is a solid cylinder or disc that fit snugly into hollow cylinder and move back and forth under the pressure of fluid, which is typically a hot gas formed by combustion, same as in many types of engine, and move or compress a fluid as in a pump or compressor. In our assignment, the piston have divided into 4 parts. The part 1 is the connecting rod. It is the part of the piston engine which connects the piston to the crankshaft. Together with the crank, the connecting of the rod converts the reciprocating motion of the piston into rotational of the crankshaft. This is also one of the connecting rod part. The part 3 is whip-spin, which is connect the piston of the connecting rod and provide a bearing for a connecting rod to pivot open as the piston moves. Part 4 is piston head. It is the top surface of the piston, which is subjected to the tremendous force and heat during the normal engine operation. Finally, we assemble all the parts, it will become a whole piston. They have 2 main manufacturing processes in piston, which are forging and casting process. Forging process will be start by bringing a cast aluminum alloy. The reason is it is a very lightweight and easy to cut. Then go to the fullering and aging process, which are used to distribute the material when reshaping the blank of forging. Then blocking will be done based on the requirement of the design. After trimming flush, a forged piston is done. This picture shows the connecting rod in forging process.
So I'm going to present the manufacturing of piston head by casting process. Just like my team member Enkaisin have present the foundry process. The third will be the CNC lathe machining. So at first the skirt of the piston is finished, and after that the CNC is programmed to A. So cut the grooves B and then make an accurate bore diameter C. Then finish the crown. The fourth will be the 5-axis VMC machining. In this machine, the all slots and pin bore is made. So the fifth one is grinding. So this process involves the final size being machined of a piston. The grinder machines the skirt of the piston only, and in the majority of cases is cam ground. Cam grinding ensures the piston will grow evenly in the bore of the engine. And lastly, the final inspection. At this stage, the piston is clean, fitted with the appropriate wrist pin, stamped with the piston's oversize and other markings, and then sent to dispatch.
To doing the analysis of assembly piston, the SolidWorks simulation are used to test the piston. The two testing we have, which are pressure test and thermal test. For the pressure test, 120 Newton per square meter is applied on the piston. The red color arrow is the part to apply pressure, and the green arrow is the part to fix the piston. Once we have successfully run the simulation, there are a few options represent the data, which are thrust, displacement, and strength. For the thrust chart, we can see the lower and the middle level of the thrust. For the displacement, we can see the maximum displacement on the head of the piston. Then for the strength, the body of the piston show that have the middle level of the strength.
The second test simulation that I'll be using is the thermal test. So the temperature that we key in is 250 Kelvin with the convection of 250 volts with the heat power of 100 watts per item, while piston is in the engine, so all the surfaces are exposed in the engine. All the surfaces are exposed for the temperature. So this is for the thermal temperature. Piston head heats the most. This is the displacement test. Thank you.